Hey everybody, this is Alex Merced, and you're listening to another episode of Data Nation. And on this episode, what I want to do is talk about a really amazing feature of the Dremio query engine. So if you don't use Dremio for your analytics, you really should. You'll see why as I talk about it in this episode. But one of the sort of the secret sauce features of the Dremio platform is a feature called reflections. Um, to kind of understand and appreciate reflections deeper, let's just talk about sort of like what you would do before reflections to kind of fill the sort of the same need. So imagine this: you have a 10 terabyte table or a 10 petabyte table that you want to query. Now, if you were just to scan all 10 petabytes of data to run a query, it could take a while to run that query. So there's different techniques that you use to sort of speed that up. Okay, there are things like partitioning, where basically you physically sort of separate the data based on a value on, one or more columns. Okay, so imagine if we're thinking about like data about far as like voters, you might want to partition it based on like political parties. So that way all the red team voters are in one partition, all the green team are in one partition, all the blue team, all the yellow team, they're all in their own separate physical data files. So that way, if I'm running a query, hey, give me all the voters of green team, it's only scanning those files, it separates that out. To make it even faster, I might take each of those partitions and I might sort them. Okay, so then maybe each of those partitions are sorted by state. Okay, so that way, when I go say, hey, give me all the green team members for only the state of Michigan, okay, it's going to end up scanning a lot less data files because all those Michigan green voters are going to be clustered among smaller files. Okay, and that's all fine and good, and that definitely helps speed things up. But sometimes, even within that, there might be just a certain subset of that data that doesn't fall within the way you've partitioned or sorted your table that you are planning to do several scans on, and you don't want to have to like re-get that subset of the data every single time. So what you would do is you would create what's called a materialized view. Okay, this is different than your standard view. So a standard SQL view is just essentially you're just taking an SQL query and giving it a name. So if I run this SQL query all the time, I might call it just, I'll give it a name like Bob. Okay, now instead of me having to say, hey, select all, where this, blah, 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 I just say Bob. Okay, select all from Bob. And essentially what I'm doing is I'm saying, hey, I want to see all the results from that particular query. And that just basically makes me referring to that faster. But at the end of the day, the engine, the underlying querying tool, is still running that full query. It's still running all that processing. A materialized view, what they do is they take the results of that query, you give it a separate name, like Bob, except it's actually creating a physical copy. Okay, so essentially you're not running that query again, there's a separate copy of the data that you then hit that's going to be much smaller and much faster to scan. And then you can run deeper queries on that subset. And that's great, but there's a couple of problems with these traditional materialized views. One, it's under a different name. So unless I knew you created this materialized view called Bob, okay, and I'm still scanning the original table, I'm not getting the benefit of that materialized view. Okay, two, I have to keep it in sync. Okay, so what happens is that every time I update the original table that materialized view is based on, it's not going to automatically update. So then there's all these things about like, okay, how am I going to sync it up, and how often am I going to sync it up, and how do you actually mechanically do that and implement that? It gets pretty complicated. So you're making just a straight up copy of that data. Okay, so you're making a copy, so you're duplicating the space taken up for that data. And then if I want to create other materialized views, they're going to end up taking even additional space, even if they're on the same set of data. I think about syncing it, and it's all done under different namespaces. So meaning users have to know that these materialized views exist to benefit from them. Reflections deals with all these issues and more. Okay, so what Reflections does is that when I turn on Reflections on a particular data set, in the Dremio platform, it'll depending on what type of reflection I make, and we'll get deeper into that, it's going to create not necessarily a copy, but a physical representation. Okay, and it won't necessarily copy everything if it doesn't have to. So it'll create a smart physical representation that allows the query engine to be faster without necessarily making a one-for-one copy. Okay, and that copy isn't just like an exact copy. It's done through what's called an Apache Iceberg table. Okay, so if you're talking about, hey, I have a terabyte of Parquet files and I turn on reflections, essentially an Apache Iceberg metadata and representations of that data are being created that allow you to query that data faster. Okay, now usually you're not going to do this on the full data set. Usually you'll create views in Dremio. So again, those views are just essentially namespaces over SQL queries that you run very regularly. But you may say, hey, I run this really regularly and I want to make it faster. So you turn on reflections on that view. Okay, and I'll give you a couple different use cases where that makes a lot of sense. But when I do that, I'm going to create that materialization, but it's not just a copy. It's an Apache Iceberg table, which means you're getting all this metadata that the Iceberg spec allows the engines to query that data much faster. And the really cool thing about the Dremio platform is that representation, that reflection, can then be partitioned itself. So for example, going back to that political data, I may have originally been partitioning based on party, but maybe right now I have a view that's really just the yellow team, and you know what? I would like that data to be partitioned based on state. Okay, so that way the people in different states are just completely physically separated. So I can say, hey, create a reflection that's partitioned by state on that view. So that view already filters by yellow team. And now I'm saying, hey, create this reflection that is partitioned by state. So now you're getting this physical sort of Iceberg copy of that data that is now partitioned by state, which is going to allow you to speed up queries on that data, especially if they're typically queried by state, saying, hey, I want to get all voters of this state, all the voters of this state in this party. It's going to make it even further faster, and you can also specify other details. And a new thing is going to be that you'll be able to use Iceberg partition transforms. So in Dremio, you could already use Iceberg partition transforms when you created new tables, but now you'll be able to use them in your reflections. So that means you could actually partition that table and say, hey, I want to separate it out by buckets. So you can actually say, you know what? There's too many zip codes. I'd like to partition it based on zip code, but there's too many zip codes to say, hey, every zip code gets its own little space. So what you could do is you could do a bucket. Say, hey, take all the zip codes, separate them out into 10 unique buckets, and then split up the data that way. Okay, so that way, if I need to scan a particular zip code, I'm not scanning all the data. I'm just going to scan one of those 10 buckets. Okay, so I've just now reduced the amount of data I need to scan by like 90%. Okay, and that's going to make things a lot faster. Or truncate. Hey, you know what? I'd like to organize I want to partition by state, but I also would like to partition it based on, let's say, not necessarily by town, because you'll get too many small partitions, but let's just say the first letter of the town. Okay, so that way all the Michigan yellow team voters who live in a town that starts with M, they're in one partition, and I can use the truncate to do that. Okay, these were things. So you get these really granular partition options. So you don't have to change the way your original table is partitioned. You don't have to create a huge copy of that original table. You can create these smaller reflections that can be partitioned and optimized for the fastest query possible, depending on what your query patterns are. On top of that is that usually a materialized view only works when you query that namespace. Okay, so if I don't query Bob, I'm not hitting the materialized view. With reflections, I turn it on a table or a view, it just works. And anybody who wants to query that original table or that original view that I turned it on, they don't need to be aware that a reflection was created. They're just going to notice that their queries are faster. And if you create additional views based on that view that had the reflections turned on, they'll benefit from those reflections. So you're not having to create a separate set of reflections for every single view you create. The reflections on one view can then benefit all views that derive from that. Okay, so you see there's and then again it automatically syncs it up too. So you can set up like a refresh frequency, so that way it just keeps it in sync, and you don't have to be thinking about, hey, is this reflecting the actual data in my table? So you're making a copy of less data, because again it's going to try to figure out what's the most efficient way to create those materializations. You can optimize those materializations. You get reuse out of them across multiple views, and you don't have to worry about having to query some other namespace. So end users just keep querying the views that they've already been used to querying. They're just going to notice that it's faster. Okay, so it's just an easier to use, better experience on all fronts. Now, what are some great use cases for reflections? Oftentimes joins. So you might, instead of, you don't want to like turn on reflections on every table you have, then you are probably creating a lot more physical copying than you do. But there are some great strategies on when this makes a lot of sense. Joins. Okay, you create a reflection on the joined table, which will then accelerate that join, and then all the views derived from that join. Okay, so this is great when you're doing stuff like, like ELT type patterns, where you're doing a lot of that denormalization after you've loaded the data into your lake. So you can do a lot of that without reducing a lot of the duplication costs that might happen. Because a lot of people end up having a huge bill when they do ELT, because what they do is they'll load all the denormalized data, all the normalized data into like a warehouse like Snowflake, and then denormalize it there. And the problem is you're paying for much more for the compute in Snowflake, and you're paying much more for the storage. You're just maximizing your costs. While with Dremio, you can load it into load the normalized, meaning not joined yet, data, onto your data lake, and then you can denormalize it without having to make a physical copy of it. I mean, you'll have reflections, but again, those reflections will help really minimize, speed up the queries without necessarily you having to create like true copies that you have to worry about syncing and tracking and all this. So it makes ELT, a viable alternative to ETL. Another use case is when you're doing virtualization with Dremio. So in Dremio, you can connect things like Postgres, you can connect things like Snowflake, you can connect databases, data warehouses, and data lakes. But the problem is when you're using a data warehouse or a database, there's going to be query pushdown, which means, hey, that initial getting of the data is going to happen at the database, at the data warehouse, which is fine most of the time. But what happens if there's latency issues with that particular database or that particular data warehouse? And I'm joining data from Postgres with data from Snowflake, and one of those two is just having some latency issues that's slowing down the overall query. Well, if I create a reflection on those two virtualized data sets, okay, then I'll have those iceberg representations in my, basically available. Again, I don't have to worry about keeping them in sync. The Dremio will keep them in sync with the underlying source, okay? But the great thing is, they're going to be fast. I don't have to worry about that latency. I don't have to worry about, hey, Snowflake or Postgres having a bad day and slowing down my overall query, because Dremio will query the reflections and benefit from the reflections. So again, when you're virtualizing data, reflections make a lot of sense. When you're denormalizing data, reflections make a lot of sense. And this reflections feature really, at this sort of robust level, only exists with Dremio. It's a very unique special sauce when it comes to Dremio. So I find it quite exciting. I hope after you guys all listen to this, you find it quite exciting. But head over to Dremio.com if you want to check that out. And yes, I work at Dremio, so full disclosure. But I do find this particular feature super, super cool, which is why I like talking about it so much. But hopefully you guys found this episode, again, every time talking about different data topics. So if you haven't listened to some of my previous episodes, go listen to those previous episodes about things like AI, ETL, DAGs, all that great stuff. But again, this is Alex Merced. You're listening to Data Nation. Have a great day and enjoy.